Hello, my name is Nathaniel, and I will be presenting 8 works today. Schoenberg, Berg, and Weber were considering the abstract ideas of pitch sets in contrast to the tonal hierarchy. Alan thought was akin to Carl Linnaeus. He classified all musical sets. 2 of them are identified to be all-integral tetrachords, Z15 and Z29. For my composition, titled Invention in All-Integral Tetrachords, I used the 2 all-integral tetrachords as my pitch class sets, and this table shows what sets and what transpositions or inversions on these sets are used in this piece. If you look at part on the score, I have labeled every set I used in this part. For example, T8x is x transposed up 8 semitones, and G3IY is y inverted then transposed up 3 semitones. Let us listen to Invention in All-Integral Tetrachords. Now we will move on to serialism. Arnold Schoenberg invented another compositional technique which he called the 12-tone technique. This technique lies in the definition of a tone row. A tone row uses the pitch classes 0 to 11 and these are not repeated. 0 is back to C and 1 is back to C sharp and so on. For my composition after math, I use this series as shown for my tone row. This is the 12-tone matrix for this row which includes the 4 main transformations. Let's look at them using a representative picture. Imagine this cat picture is the row. This is also called prime form. And when we flip it vertically, this is the retrograde of the row. Flipping them horizontally will give you inversion and retrograde inversion. However, according to Solomon, we can do 4 more transformations. One of them is to flip it diagonally to get the quadrate. Doing retrograde and inversion gives the other 3 quadrate forms shown in this slide. Do note that the cat picture is to help you visualize how the numbers in the row can be flipped. It does not take note values into account. Let's look at how to read the 12-tone matrix. When you read from left to right, that is prime form. When you read from different rows, you get transpositions of the prime form. This is true for any other form. In my score, I have used P0, and in the next few slides, you will see which forms I have used for my composition after math. When you read from right to left, that is retrograde form. When you read downwards, you get inversion, and upwards is retrograde inversion. These tables show the prime and quadrate forms I used in my music. Let's listen to aftermath. Minimalism was a movement that started in the mid-20th century, which involves as minimal elements as possible to create music. One such technique used is repeating 2 or more different melodic lines with different periods to create another line that is longer. Prime numbers are used to avoid the periods from coinciding for as far as possible. In my piece Carnival, I used prime numbers 7, 11, 13 and 29 to create the length of the melodic periods. The last period is of length 18 and is used for contrast against the prime-dominated atmosphere. Let's listen to Carnival. While you just heard Resultant Harmony, we will hear Resultant Rhythm. Phasing was discovered by Steve Reich when he tried to synchronize two tapes but can't. Phasing is explained as follows. The two figures are in unison. Then the bottom figure is shifted by one semiquaver to the left. For both figures to start at the same time, the first semiquaver is shifted to the end of the figure. Phasing can also be done in larger intervals like phasing by 3 semiquavers. For my composition, I used the number 1, 2, 3, 4, 5, 6, 7, 8, 9, then converted it into binary to obtain this string of 1s and 0s. A 1 is converted into a semiquaver and a 0 to a semiquaver rest. Let us listen to missing 8. We are now going to look at integral serialism, which includes the serialization of other elements other than pitch. One of the main proponents of integral serialism was Pierre Boulez. Using his technique, I composed Euler's dilemma based on Euler's number. And here is my integral serialism table using Boulez's technique of composition. The pitch, rhythm, dynamics, and time signatures all follow Euler's number. There are some numbers in my score. The black numbers indicate pitch and rhythm, and the blue numbers indicate dynamics. And the time signatures follow Euler's number starting at bar 6. Let us listen to Euler's dilemma. Musical modes have a very interesting history, but it has changed to the 7 diatonic modes we know. Other cultures around the world had different varieties of modes, such as the 10 Indian thoughts, or pentatonic scales, and many more. For this piece Microcosm, I used all 7 of the diatonic modes. The major pentatonic scale, in Chinese it's called the gong mode, the minor thought, in the Western world it's called the double harmonic scale, and the Selangor scale, which stems from the Indonesian gamelan. It also includes microtones, hence it is approximated as shown here. I selected these scales to represent the multicultural environment I am living in Singapore. I have also color-coded the modes for ease of viewing. Let us listen to Microcosm. section of works, we will be listening to some relaxing music. This jazz reharmonization uses bars 10 to 25 from the original orchestral piece titled Moonlight. And here is the piano reduction of the full score. In my jazz reharmonization, the main melody is highlighted in blue. I've extended the chords to include 7s, 9s, 11s, and 13s. In my score, the black chords are chordal extensions of the original. In addition, I also substituted some chords from a completely different one, and the green chords are substitutions of the original. There is melodic improvisation for bar 11, keeping the chords established in the previous bars. I also added in a few jazz modes to create variety. Let us listen to Moonlight. This is the end of my folio. I hope you enjoyed it. Thank you.